Hello! Welcome to today's lesson on free body diagrams. In today's lesson, we will begin by understanding free body diagrams as visual tools used to represent all the forces acting on an object. Next, we'll break down the meaning behind the key features of these diagrams, including the labels, arrows, and objects highlighted. Finally, we will explain the utility of free body diagrams in physical scenarios. You already have an intuitive understanding of forces. We've looked at how different kinds of forces act on objects, such as pushes, pulls, friction, and gravity. This foundation helps us understand the movement and interaction of objects. Building on this understanding, we can now introduce free body diagrams, which will enhance our ability to visualize and analyze the forces acting on an object. Let's get started!
So, what are free body diagrams?
Free body diagrams, often abbreviated as FBDs, are crucial tools in physics for visualizing and analyzing the forces acting on an object. They provide a simplified representation of a situation by focusing solely on the forces, making complex scenarios easier to handle. There are three core components of a free body diagram. Let's break these down one by one, starting with the object. In a free body diagram, the object in question is typically represented by a simple shape, such as a dot or a square. This simplicity helps focus our attention on the forces rather than the object's details. Then we have the arrows, which are used to symbolize forces. Each arrow points in the direction of the force it represents, and its length indicates the magnitude or size of the force. For example, a longer arrow represents a larger force. Finally, there are labels. Each arrow is labeled to show what force it represents. Common labels include F for applied force, W or mg for weight or force of gravity, and finally N for normal force, which is the support force from surfaces like floors or tables. So why use free body diagrams? Free body diagrams help us see all the forces acting on an object clearly and simultaneously. This way we can easily identify which forces are balanced, unbalanced, and how they influence the object's motion. Imagine someone pushing a heavy box along the floor. By visualizing this as a free body diagram, we can gain a better understanding of what forces are acting on the object and which direction it will move in. Additionally, by visualizing the forces, we can infer how the object's motion will change. For instance, if we notice a large arrow pointing to the right and small arrows opposing it, we can predict that the object will accelerate to the right. In today's lesson, we delved into free body diagrams and their critical role in visualizing and analyzing forces acting on an object. We covered the essential components of free body diagrams, including representing the object with a simple shape, using arrows to indicate the direction and magnitude of forces, and labeling each force clearly. Finally, we looked at why using free body diagrams is useful in seeing the forces clearly and assessing the overall motion of the object. By understanding how these forces interact, we can determine the resultant motion of the box, which we will explore in our next lesson. Watch the rest of the GCSE physics course at Sophos Education.